Hello friends, welcome to Learner's Planet. So this is our second theory session for the topic coal and petroleum. We have discussed about the formation of coal, about the different types of coal, and also about the manufacture of coke. In this session, we are going to discuss about petroleum. How it was formed millions of years ago. See, it is formed by the burning of marine organisms that died and settled in the ocean floor. So about the formation of petrol and also about the extraction of petrol. And we'll also discuss about the natural gas. So let's start our session here. Petroleum and natural gas was formed from the remains of tiny marine organisms that died millions of years ago. Marine organisms, the organisms which live in sea, they are called as marine organisms. See, the small marine organisms, they died and they settled at the ocean floor. Some 300 to 400 million years ago. It is why. 300 to 400 million years ago. Then what happened? See, there was sediments of rocks. The porous sediments, then the impermeable rock, the sedimented rock. So this was, but over time, it got covered with the porous sediments of rocks or sediments in the rocks. This is some 50 to 100 million years ago. Here, now these organisms, they were acted upon by bacteria, or microorganisms, and they turn into oil. So it's today, these are trapped, this is the trapped oil, these are the trapped gases, and this is drilled, right? So how is this petroleum formed? The tiny microorganisms that died and that settled at the bottom, this ocean floor. They were covered by the sediments of rocks. They were covered by the sediments of, say, sand of the rocks. Then due to the enormous heat and pressure, these remains were transformed into oil and natural gas. This oil and natural gas, this rising through the porous rocks such as sandstone. These are the porous rocks. Sandstone, petroleum and natural gas reached a layer of impermeable rock and were trapped below it. See, oil and natural gas, they rose from these porous rocks and they were trapped in this impermeable rocks. And then they were drilled from it there. Let's see how this petroleum is drilled out. See, this is the impervious rock. That is a porous rock. From here, the petroleum moved out. And this is trapped below the impermeable rock. This is also the impermeable rock, right? And this is then drilled out. Petroleum reserves exist as oil or gas within trapping sections of reservoir rock formed by structural or stratigraphic geological features. That is, it's the layers of the rock, the formation of the layers of rocks over the trapped organisms, over the dead organisms. Water is the predominant fluid. Obviously, it is the marine conditions. The ocean is there, so water is the predominant fluid, found in the permeability and porosity of subsurface strata within the Earth's crust. Both oil and gas have a low specific gravity relative to water and will thus float through the more porous sections of reservoir rock from their source area to the surface, unless restrained by a trap. So we have seen it here. The oil and natural gas are formed. They'll move through this more porous sections of the rocks. They'll move up. Why? Because they have got low surface gravity. Low specific gravity. So they'll move out. Not move out, they'll move up, leaving water beneath. Both, this I have told you, they'll move through the porous rocks. Typically, reservoir rock consists of sand, sandstone, limestone or dolomite. So they'll come to the reservoir rock. From the bottom, from the beneath or from down, they'll come up. And they'll be held by the sand or sandstone or limestone or dolomite. A trap is a reservoir that is overlain by dense cap rock or zone of very low or no porosity that restrains migrating hydrocarbon. Now the trap where the oil finally comes, it has no porosity and thus it restrains the further movement of oil. See, here you can see the oil and natural gas, they are moving through this pores of the rocks, the porous sedimentary rock. And they have got trapped in this impermeable rock. This rock doesn't have any pore. So they are trapped over here. The oil and the gas. The oil will be trapped below the impermeable rock and the gas will be trapped in the, this will be trapped just above the oil and in the impermeable rock. That is a trap. Petroleum bearing reservoirs can exist from surface seeps to the subsurface depths over 4 meter or 6.5 kilometer below the sea level. It should not be 4, it is over 6.4 kilometer. Over 6.4 kilometer below the sea level. Reservoirs vary from being quite small to covering several thousands of acres and range in thickness from few inches to hundreds of feet or more. And petroleum and natural gas are extracted by drilling through the impermeable rock. See, this drilling has been done from this impermeable rock. Petroleum has moved up through the porous rocks and it is held over here, and drilling is done through this impermeable rock and it is extracted. The crude oil or the oil which is extracted is a mixture of solid, liquid and gaseous hydrocarbons, and it is separated by refining of petroleum. This refining is done in oil refineries. Say it is a fractional distillating column, or here the fractional distillation takes place. That is, it is a column in which there are different temperatures at different heights. Say it's 600 degrees centigrade below and 20 degrees centigrade above. Right? So now on the top there are fractions decreasing by density and boiling point. The fractions which have got less density and also less boiling point are above. And the fractions which have got high density and high boiling point are below. Crude oil is fetched over here. And what happens? This is the distillation column. This is called as here, this fractional distillation is taking place in this oil refinery. So that at the top, what is obtained is a liquefied petroleum gas. And here the temperature is around 20 degrees. At the these are the hydrocarbons, or you can say LPG. It consists of the hydrocarbons which have got very low boiling points. Right? Then at around 70 degrees, this naphtha is obtained. Some chemicals are obtained. See, down the fractionating column, what happens? The density increases. At 120 degree, gasoline is obtained. That is a highly purified petrol. At 170 degree, jet fuel is obtained. Right? Or the kerosene. Below it, kerosene is obtained. And then as the diesel oil, the train fuel, the lubricating oils are obtained below it, and below it the fuel oil is obtained for ships and factories. And the residue is having the carbon number more than 70, and that is used for making roads. So this is how the refining of petroleum is done. Okay. Petroleum or crude oil, I have told you, is a complex mixture of solid, liquid and gaseous hydrocarbons. Refining of petroleum is done for the separation of useful substances in oil refineries. In this process, what happens? petroleum or that a crude oil which is obtained is heated to 400 degrees centigrades and introduced in fractionating column. This is not petroleum, it is crude oil, right? Crude oil which is obtained after drilling is heated to 400 degrees centigrades and introduced in fractionating column, which is a tall and cylindrical structures fitted with horizontal trays. As the vapors of petroleum rise inside the fractionating column, they cool and they condense at different heights, depending on their boiling points, and are collected in different trays. Uncondensed hydrocarbons pass out of the column. This we have seen here, that that crude oil is heated to 400 degrees centigrades and then it is fetched into this fractionating column, and it gets settled at these vapors, they get settled at the different trays which are at different temperatures. This is how petroleum is refined. There are different temperatures at different levels. Say at 170 degrees centigrades around to 120 degrees, petrol is the vapors, they condense and they form petrol. Fine. It is not directly ignited, the crude oil, it is heated at to 400 degrees centigrades and it is introduced in the fractionating column. And at different temperatures, the vapors get settled or condensed and they form different segments. And they form different types of chemicals. Or you can say the different types of fuels which are used. The refining process is also called the fractional distillation of petroleum, of crude oil. Natural gas, it consists mainly of methane. It is used for generation of electricity. Compressed natural gas is used as fuel in automobiles as it is more environment friendly than petrol or diesel. It is also used as domestic fuel. It is used in the production of ammonia. It is used to produce hydrogen. It is also used in the manufacture of steel, gas, plastics and other products. See, it is the main products. This should not be the heading. It is natural gas only. The main products I have told you. Liquefied petroleum gas, chemicals, gasoline, kerosene, diesel, lubricating oil, fuel oil, all are obtained. Natural gas, which is say formed with the petrol, it has got following uses. Right? See, fossil fuels have got high calorific value, but there are certain limitations also. So the main limitations are the limited availability in nature. Obviously, they are exhaustible natural resource or non-renewable natural resource. So they've got limited availability in nature, and secondly, they also cause air pollution. Why limited availability? Say fossil fuels take millions of years to form. If we run out of existing stock, these fuels or existing stocks of these fuels will not get more until natural processes have regenerated them. These fossil fuels have formed in millions of years. It has taken millions of years for the formation of these fossil fuels. And if we run out of it, we are not going to get it again. The second aspect is the air pollution. So I have told you that these fuels, they undergo combustion, forming carbon dioxide and water. Carbon dioxide is the main gas which is formed. And in case of incomplete combustion, what is formed is the products are carbon, carbon monoxide and water. And even this is harmful or dangerous. The addition, and also together with it, the addition of undesirable substances to the air is air pollution. This you all know. These have got adverse effect on the organisms. This you also know. So these are releasing these gases. Now these gases, this carbon dioxide, is a greenhouse gas. Carbon monoxide is poisonous. So these gases, they are added up in the air and thus causing air pollution. Carbon monoxide, it is a colorless, odorless and tasteless gas. I have told you that it is formed by the incomplete combustion of the substance. And this exposure to carbon monoxide may cause headache, dizziness and even can lead to coma and death if you're exposed to high amount of carbon monoxide. It is a poisonous gas. Carbon dioxide, it is formed. Say after the complete combustion also, what is formed is carbon dioxide. This carbon dioxide levels in the atmosphere have increased due to the widespread combustion of fossil fuels. So due to the excess use of these fossil fuels, carbon dioxide levels in the atmosphere have increased. This carbon dioxide is a greenhouse gas which can lead to increase in global average temperature. Due to this increased temperature, it can cause melting of polar ice caps and glaciers. This can further result in a rise in sea level and submerging of coastal areas. I'll show you this greenhouse effect by a picture. See how this global greenhouse effect takes place. The fossil fuels are used by the automobiles and also in the industries, the small scale factories. So these are used. They emit gases. They emit carbon dioxide and many other gases. The main greenhouse gases, that is the carbon dioxide, is obtained from fossil fuels. Methane from the farm animals. The cow. Cow is the animal which gives out methane while exhalation. That is the only animal. Nitrous oxide from vehicles. So these are the gases. Now they rise up in the atmosphere and they form a layer over it. So a blanket of these gases is formed. Now these greenhouse gases trap much of the energy that the earth radiates out towards the space. More gases increase the temperature. So more is the gas, the more is the temperature. Solar energy, so this is the incoming solar energy. The solar energy comes in. But when it is escaping out, what happens? These gases, they absorb the energy. They absorb the energy radiating from the earth. And this energy is reflected back to the earth. See, this much of energy is radiated from the earth, but a very small amount of it escapes out. Rest remains in the atmosphere. Right? Solar energy, again here, some of them is reflected back and some is absorbed in the earth's atmosphere, some reaches the earth's surface. In a way, what happens that the energy radiated back from the earth is absorbed by these gases. A very small amount of energy goes out or escapes the atmosphere, which increases the temperature. Right? Now, as the temperature is increasing, what will happen? The polar ice caps will melt and thus will increase the water level in the oceans, and they can cause the flooding. They can cause the submerging of the coastal areas. Right? This is how fossil fuels are harmful for us, the use of fossil fuels. See, this is one more picture depicting the greenhouse effect. Incoming solar radiation. This is warm Earth's surface. Right? This is atmosphere carbon store, that is the carbon dioxide produced by fossil fuels. It is absorbing the energy. The energy is reflected back by the earth and its atmosphere. This energy is then absorbed by the greenhouse gases. The greenhouse gases let the sun's short-wave radiation reach the earth, but trap some of the long-wave infrared heat radiation coming from the warm earth. So infrared heat radiation is emitted from the earth's surface, but this is trapped by the greenhouse gases and thus increasing the earth's temperature. Right? So the sun is giving out the short wave radiations, whereas the earth is giving back the long wave radiations or the infrared radiations, which can't escape the earth's atmosphere, but it is absorbed by the greenhouse gases, like the carbon dioxide, like nitrogen oxides, like methane. And thus it is leading to the global warming. So this is one of the major drawbacks of using fossil fuels. Sulfur dioxide is released when coal is burnt. Use of fossil fuels such as petrol, diesel and coal also release oxides of nitrogen. These gases react with oxygen and water vapor present in the air to produce dilute solutions of sulfuric acid and nitric acid, which fall on earth as acid rain and damage plants, aquatic life, soil and buildings. Sulfur dioxide, which is produced by burning coal, reacts with water at the time of rainfall and it forms sulfuric acid. Right here, first of all, this H2SO3 is formed. H2SO3 is formed, which further changes to H2SO4. This is dilute, very, very dilute. Likewise, nitrogen dioxide reacts with water. That is also the gas formed by released by burning of the fossil fuels, the coal, leading to the formation of HNO3. Right? This is how the acid rain occurs, and this acid rain damages the aquatic life, damages the plants and also the buildings. Soot particles are introduced in the air due to incomplete combustion of wood and fossil fuels such as coal and petroleum. Incomplete combustion. I have told you that it leads to the formation of carbon, carbon monoxide and water. Carbon forms the soot, that black particle which settles down when the wood is burnt. These particles can enter our bodies when we breathe and trigger asthma attacks and cause wheezing, coughing and respiratory irritation. So this is the limitation of fossil fuel. But still, we have no choice. We have to use it. We have to generate energy until the alternative sources of energy are there, which are extremely pollution free, which do not release these harmful gases. But for now, we have got this fossil fuels. We have got petrol, we have got diesel. It's that we can restrict the use of petrol. So instead of using an automobile for going for a short distances, we can just walk over. That will also save the petrol and also reduce the pollution. Conservation of fossil fuel, I told you, is very, very important. And we should keep in mind that we should use the fossil fuels judiciously. And also we should use the alternate sources of energy such as tidal power, wind energy, solar energy, biofuel should be increased to meet our fuel and energy needs. So keeping in mind the limitations of fossil fuels, the need of the hour is to conserve them to the extent possible. This calls for judicious use of existing resources and also the use of alternate sources of energy such as tidal power, wind energy, solar energy, biofuel to meet our fuel and energy needs. So students, fuels are important, though they are causing pollution, yet they are important. So we should use it judiciously. We should not just burn everything. We should not burn paper. We should not burn the wood unnecessarily. Right? This bonfire is done and it is a wastage of energy and it is also causing lots of pollution. It's just for fun. Fun can be done in other ways also. Then why do bonfires? Why wasting so much of wood? Why causing pollution? So use the fuel judiciously, students. It is very important for you. Now at this age, your parents might have given you vehicles, but don't use vehicles for going for a short distance. Use a bicycle or walk over. Right? I hope you have enjoyed this session and understood the importance of fuels. So now just go through the text so that the concepts are clear to you. Now I'll be concluding this session, students. I hope you have enjoyed and also understood the importance of fuels. Thank you, students, for listening patiently, and do have a nice time ahead.